Assalamu alaikum, good evening, and welcome to tonight's episode of Talking Point. I'm your host, Saeed Niaz Ahmed. At the beginning, I would like to congratulate you for 7th of March, a very important day in the history of Bangladesh, the day Sheikh Mujibur Rahman Bangabandhu delivered his 7th March lecture in Ramna ground, which was known as Race Course. He outlined the coming events and what he had planned for an independent country. And we move on to our guest today, who is, may I present him as a gift to Bangladesh, a very distinguished scientist, a chartered engineer, a chartered scientist, a chartered mathematician, Dr. Khosru Rahman. Welcome to the show, sir.
Thank you for having me.
Thank you for coming along and making time for us during these very difficult times. Last time we met, the program could not materialize because of power outage, but here we are again. Funny enough, today is also the 7th of March.
Well, let's hope we don't have the power cut we did last time.
With an electrical engineer on hand, I don't think power outage will dare look into our eyes. How are you today?
Very well, thank you, very well. Thank you.
As I said in the beginning, that you are a chartered scientist, a chartered engineer, a chartered mathematician, and you have been at so many universities, you teach at universities, you are also an expert of aerospace.
Yes, I mean, first and foremost, I am an engineer, aerospace engineer, and it's an industry that I've been in now for over 20 years,
right.
And I've worked in some of the biggest aerospace names in the industry. And
like Grenfell and BAE.
Well, yes, my initial role was at Rolls-Royce and then BAE. So in the aerospace industry, you don't get any bigger names than Rolls-Royce and BAE, certainly in the UK anyway.
So what took you from the Polytechnic to all these places?
Well, I think someone who's an engineer or a scientist, it's not something that comes by, later in life. You're either inclined to that by your way of thinking, by your personality, so you're naturally sort of inclined to be an engineer or scientist or mathematician. It's not something that you change into later on in your life. So I was always inclined very technically and in the mathematics. Now when I went to South Bank Polytechnic, I think it was 1988 back then. One of the engineering itself is a vast subject, and it covers many disciplines within the mechanical, that comes broadly within the mechanical engineering discipline. One of the areas that I particularly became fond of, or rather quite intrigued by, is the subject of what we call vibrational dynamics, and it was quite fascinating, vibrational dynamics and
vibration of machine parts, or
well, rotating machinery, machine parts, but it's really it's something. It's not an easy concept to understand, because one, to be a proficient dynamics, what we call dynamicist or vibration analyst, you need two kinds of ability or cognitive mental ability, and also the ability to understand mechanical systems. So you need to be able to picture in your mind what's happening, and then you need the mathematical ability to be able to replicate a physical system into a mathematical model, and then analyze that. So there's a very distinct disciplines you need, and not everyone has that ability
to understand.
To understand, yes.
But where will you apply this knowledge?
Well, it's applied every in any
Anything that moves?
anything that moves, yes, and even anything that doesn't move. For example, bridges don't move, but vibration.
Some vibrate.
Yeah, I mean, you heard about the famous Tacoma Narrows Bridge, 1914. It's a well-documented case, and in any civil engineering course, you'll always be taught about the Tacoma Narrows Bridge, how resonance caused the bridge to collapse. And your washing machine, for example, is a prime example of what we call a sinusoidal force response vibration, because of the basically what you have is an unbalanced rotating mass, and that subjects the washing machine what we call a sinusoidal force response. And if you actually, how do you, that's the nature of the dynamics, but how do you now model that using mathematical concepts, trying to understand how that washing machine behaves and how you can design the parameters of the washing machine, because if you take a washing machine apart, it will have springs, dampers and other elements. So how do you design for those parts? So this is where modeling comes in, and this is what I do in the aerospace industry to make sure that safety critical systems in the aerospace, in an aircraft, will function over the entire life of the aircraft.
And how long is the entire life of the aircraft?
Typically, the design life of a commercial aircraft is around 25 years. Military aircraft is around 12 years. But when we design, however, our designs has to survive typically 4 times that length of time. So we have to design it for 4 times.
But commercial airlines are being used for more than 25 years because they're redesigned and uplifted and.
They are. The engine itself, if you take because at one time the engines were part of the aircraft. So when the customer, the airline buys the aircraft, they buy the whole complete aircraft, and they're responsible. Now the situation in the aerospace industry has changed, where the engine now remains. Say, for example, you may buy a Boeing 777, but you will have a choice whether you want to put in a Pratt & Whitney engine, a Rolls-Royce engine, or a GE engine. And GE and Rolls-Royce and Pratt & Whitney remain, the ownership of the engine remains with them, because they are the people who are best placed to actually maintain the engine. So now you have, instead of the airlines or the aircraft framemakers buying the engine outright, the engine is now paid for on an hourly basis, fly by hour, the so-called. So this is why Rolls-Royce in particular and a lot of the aerospace companies have taken a huge hit, because the aircraft, all of the aircraft, are sitting on the runway and not accumulating any flying time.
Yep. Well, this is normal for all other professions as well, because 2020 has been a terrible year because of the pandemic.
Yes, yes. But we'll recover. So going back to the question, my degree, yes. So I got excited about dynamics and vibration, and this is why I went to Cranfield Institute of Technology. It's called Cranfield University now, and they had a specialist course that actually looks at it's a rotor dynamics course. Design of is rotor dynamics, and rotor dynamics studies the vibration of high-speed turbo machinery, shafts, jet engines, compressors, and that's what I did my master's on, and then.
And then you went on from Cranfield to.
I did from Cranfield. I did my PhD at Brunel University, again on rotating machinery, but specifically looking at high-speed machine tool spindles supported on multiple sets of bearing. So part of my research work was, how do we mathematically model the shaft vibration and the effects of the bearing? So modeling, how do we go about also ball bearings, tapered roller bearings. These are all the different types. They're used in any rotating machinery. They are, and if you take a jet engine, for example, there are these are. If your bearing goes on a jet engine, you've lost the engine, and if you've lost the engine, you've lost the aircraft. So well, not quite right, because the aircrafts are designed. If one engine fails, the other one is capable of flying the aircraft.
There are only 2 engines, isn't it?
Yeah, if there are two engines, it's designed such that the aircraft can fly and make it to the next airport. So it's not going to fly for, it wouldn't be able to fly, for a complete journey, but it can fly for the sufficient for the time it needs to get to the next main airport, which is typically within if it's flying over land, it's typically within half an hour's flying time.
If you're flying between London and New York, then you have a hard choice.
Well, yeah, theoretically, yes, you could. All aircrafts can be flown on one engine, except obviously for helicopters. That's a different issue.
It can land anywhere, almost. Is there any way that we can make aircrafts safer than what they are today?
I think the aircrafts are very, very safe than they than they ever were. And if you look at the number of aircraft flying around, the number of the millions of people being moved around, it's a phenomenal number, and the accident rate of aircraft is far less than what you see in the road accident. So aircrafts inherently are very, because the amount of testing and the amount of testing work that we have to do, and this, like I said earlier, when I design a safety critical flight control system, I have to design it not for one life, but for multiple lives to make sure that we have sufficient design margins. And then on top of that, we have to go through a stringent test program.
But aircrafts are run like buses, isn't it? I mean, there is not enough resting time for them. They are going from one place to another place to another place to another place. And probably they have a fixed time for servicing like our cars.
Well, they do. I mean, if you take the engine, for example, the Rolls-Royce engines are there are parts, because each time an aircraft is flying or is in use, you're consuming what we call the fatigue life, because everything has a life. So every time you're flying, you are consuming the fatigue life of your components. So there are components within the engine where at some point, which Rolls-Royce would know, that these parts would have to be changed. Whether they failed or not is relevant, but the theoretical fatigue life that they've calculated, or and if it reaches that flying hours that it's designed for, then that component has to be changed. So the aircraft will be put in the hangars, the engine taken down, stripped out, and that component and whatever other components that needs to be changed, that will be changed.
Metal fatigue, the body itself.
Well, the body is designed for a 25-year
non-stop service?
Yeah. I mean, most of the accidents, if you look at that do occur nowadays, are not so much. Very rare do you get an accident that's really engineered because of engineering deficiency or engineering related. It's a lot of the accidents over the years has always been due to maintenance errors or errors caused by people. Not so much. There was an incident. I think many years back, we lost an aircraft was lost over the I think it was a French. It was flying back from South America, and during the service, what they have to do is cover various, because there are various sensors all over, the air sensors, and the service personnel covered a small hole which traced an air pressure.
We need to take a break right now.
Okay.
And when we come back, we'll pick up the thread and the holes. Yeah. Okay, thank you for being with us. We'll be back soon after this very short break. Thank you. Welcome back. Just before the break, we were talking about different aspects of spindles and bearing and all that. And our guest today, he is a scientist, an engineer, a mathematician, and he has a lot of knowledge about many things that he is going to share with us. And he has something closer to his heart about the ethics. But we'll come to that. Before that, your dissertation for your MS was fracture or fractive mechanics. Analysis of metallic railway bridges.
Yes, that was. I did a master's degree a few years back through it's a long distance.
Yeah.
It's not long distance learning.
Distance learning, yes.
Distance learning, and I did that over three. The course was over 5 years, but I completed it within 3 years. So I received my MSc with distinction. So quite pleased about that on bridge engineering. And my dissertation, as you say, I think you didn't credit all correctly. It was on fraction mechanics analysis of a riveted truss railway bridge.
Yes.
Yeah, the fraction mechanics is a science, is another mechanical engineering subject, and it's the science of crack propagation. If you crack propagation under under cyclic loads. So bridges are particularly prone to fatigue crashing, because every time a train goes over, it subjects the bridge to what we call a cyclic load. So if you have a crack, or that crack, each time a train goes, that crack will open up, and because there's so much redundancy in the design, so initially it may not be an issue, but as the crack keeps growing, it will reach the point of what we call instability, and then at which point, what we call that it'll suffer from what we call a fast fracture, where the remaining material is insufficient to take the load of the train, and hence you can have a catastrophic railway bridge, well, a bridge failure.
It's funny, it reminds me of Tower Bridge, because the speed limit on Tower Bridge is 20 miles, see. And when I come to the studios, every time I have to cross over.
Yeah, there's two reasons for that. One, well, the 20 miles per hour, it seems like a standard sort of speed limit to reduce, I guess, congestion and pollution across the whole of London. But Tower Bridge is an old bridge, and it's a protected bridge. So what you can't do is that bridge has to be protected, and it's probably because of its historical importance and significance.
Iconic.
Yeah, so you're not going to have heavy loads. They're not going to allow very heavy lorries or heavy loads constantly going over the Tower Bridge. And it's the same with old railway bridges as well. If you take I did a talk a few years back on the Hardinge Bridge, in Bangladesh. Now that bridge is now protected under UNESCO. So those kind of bridges, because
how old is that?
It's over 100 years. It was over 100 years. It's over 100 years old now. It was built in I think it was commissioned in 1895, and it's sort of open to traffic just in the early sort of 1900.
And it's named after Lord Hardinge.
It's named after Lord Hardinge, the last viceroy of India.
There is something to do with Hardinge in Calcutta, I remember. I came across maybe Hardinge Park or something.
Yeah, maybe, but if you actually look at the history of how the bridge was, it's quite unique and quite interesting. I delivered a talk to the Institution of Mechanical Engineers on how the Hardinge bridge was built, and it's quite fascinating.
Last time we met, see, you were mentioning a bridge in France. I follow the names. You see, you're talking about it's so high, it's above the clouds.
Yeah, I think it's about 300. It's over 300 feet high. It's a Millau viaduct, and it crosses over a valley where in the morning the mist creates a fog, and from a distance it looks like the bridge is floating above the cloud, which is a beautiful sight.
A heavenly structure.
Yes.
And how long is that bridge? Viaduct?
Yeah, I'm not sure in terms of length. At least, I can't from my head remember the length. But going back to the Hardinge Bridge, that at the time when that was the longest railway bridge in the world. Even by today's standard, it is long. It's 2 miles long. Even by today's standards, it's still a long bridge.
There's a lot of talk about the bridge over Padma River in Bangladesh. Have you had time to look at it?
No, it's not a bridge that I've looked at. No.
That's a different kind of bridge, isn't it? I mean, they've got their pylons, and then it seems like ready-made things, and they're being fixed like Legos.
Yeah, I mean the Padma Bridge was actually the person who worked on the design of the bridge was my was one of my lecturers at the University of Surrey. He was directly involved with the build of that bridge, which is
and
quite interesting.
it's about several kilometers, isn't it?
Yeah, I'm not sure about.
Yeah.
I don't know much about. But anyway, going back to the bridge, I think you talked about vibration. I delivered a talk to the IMechE, looking at how we can model. This was only last week. I actually did the talk. Was it week before? I developed a mathematical model to model moving loads over a bridge and the impact that would have on the fatigue life of the bridge. And I presented that at a conference the year before at BUET, Bangladesh Engineering University. And they were quite surprised because this was an international conference. This is the first time they had an aerospace engineer talking about mathematical modelling of bridges. So which was really quite unique for them, because it's not, you don't normally get an aerospace engineer to talk about bridge vibrations.
But you call yourself an aerospace engineer by choice, isn't it? But you are also a civil engineer. I'm
not really a civil engineer. It's something that I did out of interest, and it's something I teach at the University of Greenwich as well. One of the things I'm doing at the University of Greenwich, because I've been appointed as the Royal Academy of Engineering visiting professor at the university, so as part of that role, I have to impart some of my engineering industry knowledge, technical knowledge. So what I try and do as part of that role is one, I want to do some of the things that I like, which is mathematical modeling, bridge engineering. But what I'm also doing is developing an avionics module for them, which is going to be unique, because there is, at the moment in the UK, there is no university actually that does avionics engineering. So Greenwich when I'm due to deliver that module from next September. So I'm still developing the module for them, and it will be the first university in the UK that will have an avionics engineering module. So it's quite
Not
unique.
even at Oxford? Not even at Oxford?
Well, Oxford is not a really an aerospace. They do have a lot of projects from Rolls-Royce, but they're not an aerospace. Aerospace is not a core subject area for them. So there's only a few universities that have within their departments aerospace as the core subject.
I remember having interviewed a Bangladeshi young man, Iftikhar, I think, and he was working on hypersonic or something aircrafts, and he was working on their bodies because they might heat up because of going at that speed and all. Well, very fascinating, but that can only be used in the outer space.
Yes, but first you have to get to some ridiculous speed to be able to get the hypersonic ramjet working.
But they have got labs like that, they have tunnels like that, and they are creating possibly artificial environments and trying to achieve that kind of a speed to test. Otherwise, all this work will not be, if it's not tested like the vaccines, if they are not tested, they are not convincing. You were at the Royal Academy of Engineering visiting professor, University of Greenwich, October 2019 to present. See, and this is mechanical engineering that you are.
The presentations, is that? Yeah, I did a presentation for the Royal Academy of Engineering, and it's it's really an aerospace presentation, and the subject was on sign and designing for sign on random vibration. So again, it's a very specialized subject area. Specifically, obviously I focus on the aerospace industry, but equally when we talk about sign vibration, again the washing machine comes into mind. That's something that is subjected to what we call a force vibration, sign vibration. Random vibration is slightly different, but by name, random means you can't. It's very difficult. With sign vibration, you can predict what's going to happen at some point in the future using past data. Random vibration, you can't predict based on past data because it's random. So what you have to use is what we call statistical methods to obtain a probability of occurrence of something in the future. So the analysis, analyzing sine and random are completely different. And in the aircraft environment, you have both sine vibration as well as sine on random. The best example, for example, is the helicopter. For example, the helicopter sine vibration is from the rotation of the rotor, of the gearbox, and you see specific sort of pulses. If you put a sensor on the body, you can see specific pulses at certain frequencies, depending on the frequency of the rotor or the tail rotor. And because you have all the effects of wind and every other component vibrating, you also get like a background random, call it random noise, for example. So on random noise, you have superimposed sine vibration, and you get a complex vibration profile. And how do we go about analyzing under those conditions to predict a fatigue life of a mechanical structure?
That's a very interesting thing that you mentioned, helicopters, you see. All of the aircrafts, they look pretty solid, you see. But helicopter, maybe because the way it's made, it doesn't look solid, and it seems very, very prone to dangers and accidents.
Yeah, I mean, the helicopter is, when you actually look at a helicopter and you look at the engine, all the moving parts, it is still amazing how the ingenuity of the engineers, all of the people involved who design helicopters is still amazing. I mean, the helicopter, I mean, I've worked on mostly on fast jets, i.e. military aircrafts, as well as military helicopters. Those are my two areas where I've really spent most of my 20 years of work. And designing in a helicopter is very, very challenging because of the vibration environment, sine vibration as well as sine on. It is very, very challenging, and it's not easy. And but if you look at the helicopter, the way it's designed, they've designed the helicopter by looking at nature, looking at dragonflies. So so it's quite amazing how they've come, how the helicopter shape has evolved. It's evolved around a dragonfly. So if you look at a dragonfly and the helicopter, it has the same sort of outline shape.
Okay, sir, we need to take a break. And when we come back, we'll definitely go back to the ethics of learning and knowledge.
Yes.
Thank you. Thank you for being with us. We'll be back soon after this very short break. Thank you. Welcome back. We were talking to our distinguished guest today, Dr. Khosru Rahman. It's not that I have forgotten to mention that, but he was recently honored by the Queen and awarded British Empire Medal. Congratulations for that.
Thank you.
And I'm sure that my colleagues and my Chief Executive Officer also joins in to congratulate you. It's an honor and a great reward and an acknowledgement of your distinction. We want to talk about environmental ethics. You see. This is the buzzword these days, environment. You see. There have been earthquakes in New Zealand, far away. We don't care. But it is a matter of concern for all of us who are living in this world. See? Then they're talking about nearer home somewhere in Iceland, somewhere. See? So environment cannot be taken away. It's not something different. We live in this world. We use water, we use the earth, we use air. And if we pollute the water, misuse the earth, and pollute the air and water both, then how do we survive? Yes, sir.
Yeah. Just taking you back on your comment regarding the earthquake in Indonesia.
Yeah.
You said it doesn't so what? Or it doesn't affect. Well, it does affect us.
No, I said that people think that it doesn't, but it does.
It does affect. And if you look at history and what scientists are now finding is if you look at past dynasties, say for example in Egypt, for example,
right.
at one time there was they were so strong, and something happened, and it wiped that dynasty out completely.
Right.
And what scientists have realized is an earthquake that happened on the other side of the world, and it was such a huge earthquake whose eruption spewed millions of tons of ash into the atmosphere, and that ash traveled around the globe, and it was so vast that it affected the climate of the world, and affected the climate to such an extent that it ruined the agriculture of the Egyptian in Egypt for many years, and therefore they had famine and starvation, and that caused that dynasty to be wiped out. So something that happened on the other side of the world caused one dynasty on the other side of the world to disappear. So yeah, so like you said, environment, it's a very buzzword these days, and it should be, because we're really in a serious, the whole world is in such a serious condition, and even now people are talking about perhaps the COVID-19 is a punishment from God to enable us to wake up to what's really happening, because we're moving so fast now, and in this country we're living in relative comfort, but we don't see. You mentioned Bangladesh, for example. Four of the major rivers in Bangladesh have been declared by WHO as being biologically dead. Right. And when a river system becomes biologically dead, it's not something that is going to recover overnight or in 5 years. For example, the River Thames, it's only recently that salmon have started to flow back up the Thames. River Thames at one time was very polluted, but it's taken nearly 400 years for salmon to flow back up the River Thames. But they had to spend millions and millions on cleaning the River Thames up, Thames up, and spending, so there's a lot of work gone behind the scenes to restore the River Thames to its former, to get this ecosystem back. But in Bangladesh, the situation is absolutely dire. We have leather works who are dumping toxic chemicals directly into the river system, and it's completely destroying the complete ecosystem. And it's only a matter of time when people, well, it's affecting people now, and also in Bangladesh, for example, you look at respiratory disease. It's off the scale. If you actually look at statistics, it is absolutely horrendous. It is off the scale. But these things,
the pollution, air pollution.
It is, and as engineers, the environmental ethics is a subject that really is at the heart of the Islamic faith, but it's a subject that really no one really talks about or really understands. Allah has given us, everything that Allah has given you, knowledge, whatever. Allah's made me academically. He's given me the academic ability. He hasn't given many. He gives something to everyone. But whatever He does give you, it is out of His grace and out of His mercy, and there's a condition attached with that, and you have to understand what that entails. And so environmental ethics is really, I think, is intrinsically part of the Islamic faith, and the reason why we don't understand it is because we don't really understand the depth of our faith. What does it mean when we say the Shahada? When we understand, the concept of Allah in Islam, what does it all mean? Because if you truly want to know who Allah is or what Allah is not going to appear in your dreams. He's not going to talk to you. But if you want to know Allah, Allah has given you this wonderful creation, the environment in which Allah's attributes are concatenated and refracted in nature. And if you have to open your eyes to be able to appreciate that, and there is responsibility attached to that as well, because all of this that you see, Allah has given us that as an amana, as a trust, and this trust is a weighty trust. It's not something to not take notice of. It's a trust that Allah, it's a trust that even the mountains, Allah offered the trust to the mountains and to the skies, and they refused the trust out of fear. Obviously, man, we took on that trust, and so so we have to honor that trust that Allah has given us in whatever way we can. The knowledge that Allah has given me.
Man as Ashraful Makhluqat, the best of creation. So man took on.
Well, the best of creation, because one of the things with man, unlike any other creatures, is man has been given the faculty of reason and the ability to comprehend beyond his own existence, and he has not given that to any other of his creatures. That is the unique blessing that Allah has given us, and we have to acknowledge that and understand what that really entails. He hasn't given us to be proud and to be boastful and to have arrogance, because Allah, for whatever He's given, He can take it away. And He's only just shown a glimpse of His power through the COVID-19, and all of a sudden the whole world has come, more or less has come to a stop.
Has become homebound.
But the reason why we don't understand all of this is because, one, to be knowledgeable, to have gain, should be in your desire to be. We're not really. If you look at the old, Islam in its golden period, where we had immense scientists and scholars, who did tremendous, and all of this technology that you actually see now has really stemmed from those early Islamic scientists, which really don't really know about. But the key thing, and this is a lesson to anyone really, to everyone, is to have knowledge, is to have the ability to gain it is a gift from Allah. But there's a condition, to be successful, obviously you need to be aware of your responsibilities, and you need to have that desire. But ultimately you have to come to know Allah, because everything is Allah has given us so that we come to know Allah. In the Quran, there's فَعْلَمْ أَنَّهُ لَا إِلَهَ إِلَّا اللَّهِ, know that there is no God. How do you know? It is not sufficient that you just say La ilaha illallah. You have to, Allah is asking you to know that He is the Creator. And to know that He is the Creator, you have to look at His creation, the nature, the environment. But you have to look at that with humility, yes?
Right.
Not with arrogance. And this is why it's such an important aspect. In our life, if you look at the religion of Islam, Allah has defined certain things quite clearly. And those are the things that is going to get you into Jannah. So the definition of, what is the nature of the concept of Tawheed, for example, Allah is one. That's clearly defined, so there's no confusion in that. Another things is left not so clear, and there's a wisdom obviously behind that. But to gain any knowledge in any subject, you need humility, and the first part of humility is to accept that you know nothing. So that is the first step, that you know nothing, and whatever you do know is from the grace of Allah that He has, out of His mercy that He has given you. And this is something so important that people really overlook. In our Islamic tradition, there's a hadith where when Allah announced to the mountains of the world that He was going to speak to one of His prophets whilst he was going to be standing on the mountain, all of the mountains on the earth elated themselves, excited that, is it going to be me? Is it going to be me? Is Allah going to speak to His prophet on this mountain? Except for one mountain. He actually, that mountain humbled itself with humility. And guess what? Allah talked to Musa alayhi salam on that mountain, and that mountain is Mount Sinai. So and that's because of the humility and humbleness that mountain displayed upon hearing that. And so similarly, if you do not have humility...
Briefly, how do we go about it? How can we achieve our lost glory?
Well, first and foremost, civilizations depend, in my view, on two things. One is language, and followed by ethics. Language allows you to build your cognitive ability, allows you to articulate and think about abstract things, concepts. And this is something that the Quran, when the Quran was revealed, it was revealed at the time when Arabic poetry was at its highest level. And this is the instant that the Quran was revealed. And when the Quran was revealed, it elevated the people in the languages and the sciences of languages, grammar, rhetoric, logic. All of these subjects became such fundamental areas of study by the early Muslim scholars, and this is why you have the great Muslim scholar Imam al-Ghazali, who is being studied even today. His work, they cannot decipher, how he's articulated certain subjects. And this is, I think,
a poet like Rumi, he's still a bestseller.
Yeah. All of those were inspired by the Quran, by the Arabic language. And what we have lost now is we have lost, in Bangladesh, I can talk about Bangladesh, I think we have lost two things. One, we have lost our language, and we have lost ethics. And if you lose either of them, you lost your civilization. Without ethics, you have no civilization, and without language, you have no civilization. We have children now who are here, and they can't speak English, or they can't, well, when I say they can't, they speak English, obviously, but they speak what I call street English. They can't write properly, they can't articulate thoughts.
Right.
It is really a worry.
But that can be said about so many English people as well.
Exactly, yes, about all of the people. And this is why we're in this situation that we're in. And things like WhatsApp and social media, really that does not help. Because instead of reading things, now we spend too much time on social media.
It's a very interesting topic and a very interesting aspect of sharing the knowledge and getting seeking knowledge that you have mentioned, Dr. Khosru. I think we should have another discussion on this sometime in future, time permitting, because we have come to the conclusion of this show today. Thank you very much for being with us, and thank you very much for being with us, viewers. So we hope that you enjoyed the show as much as we have. Same time, same channel, next week we'll see you again.
Thank you.
Thank you. Thank you once again, Dr. Khosru.
Yeah, that's